So that was finding the zeros. So now we're going to look at working backwards. So let f be a polynomial function that has real coefficients. If a plus b, where b does not equal 0, is a 0 of the function, then the complex conjugate, a minus bi, is also a 0 of the function. So it says find the fourth degree polynomial function with real coefficients that has the given zeros, -1, 5, and 3 minus 2i. And so in the previous section, we did something similar to this. And so let's go ahead and do this example. So the first thing you want to do is go ahead and list your zeros here. So we have x equals -1, x equals 5, and x equals 3 minus 2i. They tell you that this is a fourth degree polynomial, so you should have 4 zeros listed. So the conjugate pair definition above over here tells us that if we have a complex number, then its conjugate, in this case 3 plus 2i, will also be a 0. Once you have your zeros listed, then we want to write down the factors. To get the factors, we take the -1 and move it to the left side. So to do that, I add +1 and +1. So that would be my factor. I would subtract 5 on both sides. Subtract the 3. Add the 2i. Subtract the 3. And subtract the 2i. So these are our factors. Once we do that, then we want to find a polynomial. So I'm going to call it f of x. And I don't know what the coefficient is, so I'm going to call it an. And then I'm going to list these factors. Okay, so then what we want to do is multiply out these factors. So I'm going to have an, so I'm going to multiply x times x is x squared, x times -5, -5x plus 1x minus 5. Simplify the parentheses. So we have x squared, -5x and x is -4x minus 5. And then we're going to multiply this out. X times x is x squared. X times -3 is -3x. X times -2i is -2ix. Then we start with a 3. -3 times x is -3x. -3 times -3 is +9. And -3 times -2i is +6i. And then last, we multiply 2i times x is 2ix. 2i times -3 is -6i. And 2i times -2i is -4i squared. So we want to simplify. So here we're going to have some things that are going to cross out. So I have an x squared. I'm going to write x squared. Then I have a -3x minus a 3x gives me a -6x. And then -2ix and +2ix will give me a 0. And then 6i and -6i give me a 0. And then I have negative 4i squared. Remember, your I squared, we can substitute it with a negative 1. So negative 4 times negative 1 is positive 4, plus a 9 would give me 13. So let me repeat that. So I squared gives me negative 1 times negative 4 is positive 4, plus the 9 gives me 13. So we keep multiplying out. X squared times x squared is x to the 4th. X squared times negative 6x is negative 6x cubed. X squared times 13 is positive 13x squared. Negative 4x times x squared is negative 4x cubed. Negative 4x times negative 6x is positive 24x squared. Negative 4x times 13 is negative 52x. And then negative 5 times x squared is negative 5x squared. Negative 5 times negative 6x is positive 30x. And negative 5 times 13 is negative 65. Gather your like terms. So we have 6x cubed and a negative 4x cubed. It's going to give me a negative 10x cubed. Then we have 13x squared plus 24x squared minus 5x squared. So 13 plus 24 is 37, minus 5 is 32. And then for the x, we have negative 52x plus 30. So that would be 22x. And then finally, for our constants, we have negative 65. So let's just double check our work. So we ended up with this here. X times x is x to the 4th. Negative 6x times x squared is negative 6x cubed. 13x squared minus 4x cubed plus 24x squared. 52x, negative 52x, negative 5x squared, and 30x, and negative 65. So gather like terms, x to the 4th, negative 6x cubed, minus a 4x cubed is negative 10x cubed. Then we have 13x squared plus 24x squared plus 5x squared. So that's 37 minus 5, 32x squared. And then our x's are negative 52 minus 30, 22x minus 65. Okay. So now that we have our polynomial of degree 4, we still don't know what this an is. And so that could be different possibilities, which we will, if it's not given to you other information, then we can leave it as a 1, or we just leave it as an. But in example